Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Primrose, I think it's 4 or it's IV. I can't tell. Anyways, it's one of those and it's by Willpower, channel favorite. Here are the rules. We have normal Sudoku rules apply, which means in every cell in this grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell regions, which is a box in this cage. We also have killer cages, where numbers in cages sum to the number in the top left corner of the cage. Numbers do not repeat in cages. So, for example, these 4 digits add up to 27, these 4 add up to 30, these 4 add up to 10, these 4 add up to 13, etc., etc. These 2 add up to 11. So as an example, if this were 4, this would have to be a 7 because these 2 digits must add up to 11. And that's an example of how killer cages work. We also have crop key pairs, where numbers with a white dot between them are consecutive. And, okay, this is a negative constraint in a sense. A negative constraint means that, how do you describe it? Basically, a negative constraint means that you are limited in what you can place in certain areas because of what is not there. So it says all possible white dots between numbers on the same blue line are shown. So numbers with a white dot between them are consecutive. So for example, if this were, say, a 6, this would have to be 5 or 7. But along each of these lines, that means all possible white dots between numbers on the same blue line are shown. So therefore, these cannot be consecutive. And these cannot be consecutive because we know there would be a dot on that line because all possible white dots must be shown or are shown. So basically, these cannot be consecutive and these cannot be consecutive. And that's what it means to be the negative constraint, right? Because there is no dot there on the blue line, these can never be consecutive. So these cannot be consecutive because, again, if it were on the blue line, if they were consecutive, it would be shown. Anyways, I hope that made sense as an explanation for negative constraints. You'll run into that a decent amount. But fortunately, this was good. This is helpful because instead of essentially saying anywhere in this grid, it's just around these blue lines, right? You cannot have essentially consecutive white dots, or you can't, anywhere there is no white dot on a blue line, you can't have consecutive digits. And that's what the negative constraint of the white crop key pairs means. You'll have it for other rule sets too, but this is particularly specifically for the white crop key pairs. White crop key dots. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, first things first. You have 4 digits adding up to 30, 4 digits adding up to 10. You are guaranteed that those digits have to be 1 through 4 for the 10 cage for 4 digits, 4 cells, and 6 through 9 for the 30 cage, right? Because they're all unique, remember. So killer cages, normally they have to be all unique. Well, these digits are consecutive with these digits, which are consecutive, and these digits are consecutive. So it must be 6, 7, 8, 9 in some order. So this is 6 or 9, and this is 6 or 9. So it must be next to 7 or 8. This must be 6, 7, 8, 9, but it cannot be 7 or 8 because of the 7, 8 pair in the box. So this must be 6 or 9, which forces this to be 7 or 8 and 7 or 8. Similarly, these digits are consecutive, but these are not. They must be 1, 2, 3, 4, but we're not sure in what order. Same here. Well, we have a 1, 2, 3, 4 quadruplet in the central box, which means the 1, 2, 3, 4 cannot be in the rest of the central box. We also have a 6, 9 pair and a 7, 8 pair in that box, so this must be 5. That means in the rest of row 5, we can't have a 1, 2, 3, 4 or 5 because of the 1, 2, 3, 4 quadruplet there. Therefore, this must be 6, 7, 8, or 9. This must be 6, 7, 8, or 9. But, so this is 2, 3, 4, 5, adding up with 6, 7, 8, 9 to add up to 11. The 13 cages cannot have an 8 or a 9 in it. What would you have to add up with 8 to add up to 13? You can't, right? You have to have 3 other digits adding up to 5, and that's not possible because they have to be unique. So this cannot be 8 or 9. This cannot be 8 or 9, therefore this is 6 or 7. We have a 6, 7, 6, 7 pair in row 5, which eliminates 6 and 7 in the rest of the row. So this can't be 6 or 7. This is 2, 3, with adding up with 8 and 9 to add up to 11. If you have a 6 adding up to 13, you're guaranteed to have, if it's 6, it's 1, 2, 4, and 6 to add up to 13, right? 13 minus 6 is 7. 3 digits trying to add up to 7 uniquely must be 1, 2, 4. So this is 1, 2, 4, or if it's adding up to 7, it's 1, 2, 3. So we know we have a guaranteed 1 and 2 here. This is the same. This is a guaranteed 1 or 2. We have a guaranteed 1 and 2 here. 8 and 9 are only consecutive with 7, 8, or 9. But this cannot be 9 here because of the 6, 9 pair. So this must be 9 here. Sorry, this cannot be 9 here. This is 7 or 8. We have a 7, 8, 7, 8 pair in this right-hand box, right central box. That eliminates 7 and 8 in the rest of the box. This can't be 7. This is 6. This can't be 8. This is 9. That makes this 8, which makes this 3. 9 is only consecutive with 8, so this is 8. Which makes this 7. 7's consecutive with 6 out of 6 or 9. So this must be 9 and 8 here. That can't be 8. This is 7. This is 8. This 9 eliminates 9 here, so this is 6. That makes this a 9. This can't be 6, so this must be 7. Therefore, this must be a 1, 2, 3 triplet. 3 cannot be here because of the 3 in the box. This can't be 3 either. Neither can this nor this. This is 1, 2, and 4 adding up to 7 to add up to, with the 6 to add up to 13. 4 is not consecutive with either of these digits, so this cannot be 4. This is a 1, 2 pair, which forces this to be 4 here. So 4 cannot be here, and 4 cannot be here. Where is the 4 in this 1, 2, 3, 4 cage here? It has to be one of these 2 digits here. So this cannot be 4 here, because one of these 2 is 4. 3 has to be here. 3 is only consecutive with 2 out of 1 or 2. So this is a 2, 3 pair, which eliminates 2 and 3 in the rest of the cage. This can't be 2. This is 1. This can't be 1. This is only 2 and 1 or 2 and 3. So 2 has to be one of these. So 2 cannot be in the rest of the cage. This can't be 3 because of the 2, 3 pair in the row. This can't be 2, and it can't be 1 because of the 1 in the box. So this is 4. This cannot be 4. This must be a 4 here for this cage. 4 cannot... If this were a 3, there would have to be a dot in between. But so this cannot be 3. This 4 eliminates 4 here. This is 1. 1 cannot be here. So this has to be 2. Whoops. This has to be 2, and this has to be 3. That eliminates 2 and 3 here, so this must be 1. This can't be consecutive with 1, so it can't be 2, and it must be 3. This can't be 1, 3, or 4, so this is 2. This 2 eliminates 2 here, so this is 1. This has to be 2 then. Okay, remaining digits in column 5 are 1 through 4. To add up to 27, you cannot have 2 or 1 with any of those digits, right? Because 2 would have to add up with 3 digits adding up to 25, and they have to be unique. Well, that's not possible because the most you could have is 7, 8, 9, which adds up to 24. So this is a 3, 4, 3, 4 pair, which forces this to be 1, 2, 1, 2. These 3 are all consecutive. Well, since they're all consecutive, if you have a 4 here, you would have to have a 6, 8, and 9 triplet to add up to 27. And that's not all 3 consecutive. Therefore, this must be 3, this must be 4, this must be 7, 8, 9, but 7 can't be here. So this is 7, this is consecutive with 7, and out of 8 or 9, so this is 8, and this must be 9. This 1 eliminates 1 here, so that's 2. This can't be 2, so that's 1. This must be 6, 8, and 9. 9 can't be here, so this is 9. 8 can't be consecutive here because there's no dot between them. So this is 6, this is 8. And the rest we do with just normal Sudoku. We have the ones. Where is the 1 in row 2? Can't be here because of the 1 in the box. Can't be here because of the 1 in the box. Can't be here because 1 in the column, so this must be 1. 1 has to be one of these two. What are the remaining digits in row 4? It's 1, 5, and 6, right? And 1 and 6, 6 cannot be either of these, so this must be a 6 here. 6 is only consecutive with 5 or 7, so this can't be 7 because of the 7 in the column, so this is a 5. Okay, so after that now we can just do normal Sudoku. These are a 1, 5 pair. This in this left central box, we have to have a 2 and a 5. So it's a 2, 5 pair here. That leaves the remaining digits in row 6 as a 4. So this is a 4. Row 3, the remaining digits are 3, 7, 9. This can't be 9 or 3, so that's 7. This can't be 9, so this is 3. That forces this to be a 9 here. Okay. The rest of the digits in row 7 are 4, 5, 6, 7. This can't be 4, 6, or 7, so this must be 5. This can't be 4 or 6, so this must be 7. That leaves a 4 and 6 remaining in the rest of the row. In column 6, we have the remaining digits of 4, 5, and 6. 5 cannot be here, therefore this must be 5. That leaves these two remaining digits in this box as a 3, 8 pair. The rest of column 6 has to be a 9, so this is 9. And this is a 4, 6 pair here. Okay. What else do we have? Ones. Rest of column 7 has to be 1, 2, 5, and 6. This can't be 2, so it's 1, 5, or 6. So 2 has to be one of these two digits. This can't be 1 or 6, so this is 2 or 5. And this can't be 1 or 5, so this is 2 or 6. Interesting. Rest of column 8 is 3, 5, 8, and 9. 8 and 9 cannot be here, therefore it's a 3, 5 pair. That eliminates 3, 5 in the rest of the column and the rest of the box, so this can't be 5. This must be an 8, 9 pair, and this can't be 9 because of the 9 in the row, so this is 8, this is 9. 8 eliminates 8 here, so that's 3 and 8. The rest of row 2 has to be 2, 5, and 7. Well, this can't be 5 or 7, so this is a 2, which makes this 5, which makes this 7. The 5 eliminates 5 here, so it's 1 and 5. 1 eliminates 1 here, so it's 6. 6 eliminates 6 here, so that's 2, and 6 here. So this is 4, which makes this 6. Okay. This is the remaining digit in the upper right box is a 6. That leaves this as a 3, 4, 7 triplet. This can't be 4, this can't be 7, and this can't be 3. Rest of column 9 is 1 and 2. And this can't be 2 because of the 2 in the row. So this is 1, this is 2. Where we now should have 8 ones. We do. Where's the last? We know where the last one is. It has to be here. That doesn't give us too much. Okay, let's continue. This 2 eliminates 2 here, so this must be 3, which makes this 2. That 2 eliminates 2 here, so this is 5, which makes that 2. Okay, 3 eliminates 3 here, so it's 5 and 3. 6 eliminates 6 here, so it's 4 and 6. That leaves the remaining digits as 4 and 9 in row 8. This can't be 9 because of the 9 in the column, so this is 4, this is 9. 4 eliminates 4 here, so that's 7, which makes this 3, which makes that 4. And we should be able to fill out the rest. This is 5, this is 8, and this is a 7. And that's how you solve it. Pretty straightforward, actually. Yeah, I hope that my explanation of negative constraints made sense. It was very important in this puzzle. Otherwise, you wouldn't be able to solve it. So I hope that made sense, right? Because, again, 7 and 1 aren't consecutive. 1 and 3 aren't consecutive. 6 and 8 aren't consecutive. 6 and 9 aren't consecutive. 2 and 4, 4 and 1, 1 and 3, all are not consecutive. 4 and 2 and 3 and 1 are not consecutive with each other. 9 and 6 is not consecutive. 3 and 7 are not consecutive. And 4, 1 and 2, 6 are not consecutive. That shows the negative constraint and the power of how to use those. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.